Thank you, Ron, and thank you everyone who is joining. My name is Prashant Kochawara, and I'm the Director of Product here at Trilio. And today I'm going to be presenting on the top 10 requirements for cloud native data protection. This is basically a guide or playbook that you can use for selecting the right data protection solution for your Kubernetes environment. If we look at any of the news articles around Kubernetes today, and we see that there are a lot of different solutions that are emerging in the space, there are a lot of different mergers and acquisitions that are happening in the space. So definitely, data protection is needed, but it becomes very challenging for users to navigate the space and select the right tool or the right solution that meets their needs. So what I'm going to do here is I'm going to present 10 different requirements talking about that. Firstly, I'm going to be presenting a customer problem as to why this is needed, and then talking through the 10 different requirements via a user journey. Talking about it right from the deployment aspect to doing backups to doing restores to monitoring and so on. And then finally, we'll do a quick summary as to what we've learned as part of this presentation. And if we do have time, I'll quickly show how the Trilio solution kind of addresses all these requirements and appears in a cloud native environment. So the first thing that I want to talk about is the customer problem. And the way we're going to do this is we'll break this up into two parts. One is a business perspective, and then the second one is from a technology perspective. So right off the box or right off the bat, we can all attest to this that data has been growing at a phenomenal rate. Some stats from a Forbes article that was published recently, it says that 1.7 megabytes is created by every human per second. That is phenomenal. And just in 2020 alone, the data is going to grow to 44 times of what it is today. That is to 35 zettabytes. Now that is huge, right? And today, this data has a direct impact on organizational growth because of activities like artificial intelligence and machine learning. We've all come to this point, we've all built systems and machines, but this or now is the era where we start adding intelligence into those machines as well. And the way you do that is through, machine learning, artificial intelligence, which thrives on data. So as a result, all this data that is being created needs to be protected, it needs to be stored, and it needs to be secured. Now, coming through the technical side of things, Kubernetes is erupting, and it is definitely taking over the market everywhere. Any of the analyst reports or stats you see out there will show something on similar lines, that it's growing at a 30% compounded annual growth rate, and it's going to be reaching almost multi-billions in the next couple of years as well. The reason for this is because Kubernetes enables faster software development and faster software delivery. All new applications are being developed as cloud native, and the older ones are getting re-architected. There is a lot of pressure coming in from multiple sides for adopting Kubernetes. There are multiple technologies that are converging on a Kubernetes backplane. If we think about AWS, they launched their controllers for Kubernetes. There is VMware Tanzu. There is another open source project like Crossplane, which is all bringing all the different services which are already running out there into Kubernetes. So basically, we are seeing a pressure from all angles, and the adoption of Kubernetes is becoming inevitable. Now, data protection is not new. Data protection has been around for a while. But the way you think about data protection or the way you do data protection in Kubernetes is different. There is a reason for that. And this slide is going to kind of talk about the evolution of applications and how data protection for application has changed today. So if we turn back time and look at our bare metal days where we had all these monolithic applications running within the boundaries of an operating system, the application was pretty stagnant. It was this giant application of tightly integrated components, everyone working together, again, within the boundaries of an operating system. Now, after that, we had the virtualization era where we were able to take a lot more out of the hardware on which these applications were running. But the important thing to notice over here is that the application DNA or the application framework of how they were constructed remained the same. We were able to push a lot many more applications on a physical server, but overall, the tightly integrated aspect of these monolithic applications remained the same. And now, when we look at a cloud native application, we see that these applications are completely deconstructed into smaller microservices. These microservices each have their own identity, and they could have their own persistent storage that they could be writing data to. Now, not only does the identity and the metadata surrounding these microservices needs to be protected, but the data as well needs to be protected. And traditionally we see that the traditional data protection systems have focused on the data volumes and not on the application layer. So with Kubernetes, with the rise of cloud native applications, a different way of doing data protection or different way of protecting these applications is required. Now, let's get into the requirements of a cloud native data protection or a Kubernetes data protection solution. And we'll start off with talking about why the solution needs to be cloud native or Kubernetes native. So one thing, uh, this solution, the data protection solution that you deploy, is going to be working with other cloud native applications, other Kubernetes applications. So you want to make sure that you have a single way of managing all these applications together. You would want to use kubectl to manage your data protection solution the same way you manage the rest of your applications. If you introduce any other concept like a virtual machine or something in between, you're going to rat hole yourself into a bottleneck in terms of performance sometime or later. Even from a scalability standpoint, all these cloud native applications are highly scalable. So if you do not have a cloud native or Kubernetes native data protection solution, that data protection solution is not going to be able to satisfy all the needs and the complexities or the way these other applications are scaling up and scaling down depending on usage. The other reason for being cloud native is you want to have a multi-tenant approach. You want to have scope-based installs, scope-based usage. Your product should be geared towards developers and IT admins so that both can interact with the same piece of software but deviate on their roles and permissions. Being Kubernetes native also means that all the security best practices need to be adhered to. Security is paramount in terms of Kubernetes today, and whenever you are introducing a new application, you need to ensure that it upholds the principles around securities, making sure that you're not using privileged containers, you're not using root permissions everywhere. So those aspects have to be upheld as well. And then finally, Kubernetes abstracts so many different layers to make application delivery faster that you need to be leveraging those constructs and items for your operations as well. And similarly, we do not want to be using any concepts of access nodes or anything legacy based to, again, to present a bottleneck in terms of performance when you want to scale the environment. The next aspect is what you want to back up. And from a data protection standpoint, Kubernetes focuses on applications. So your applications are what you want to protect. We heard from JJ Ashker some time ago that Helm is basically the de facto tool used in Kubernetes for application management and tooling. So when you're protecting your applications, you want to make sure that you are protecting these applications along with the tooling that comes with it. So your solution should be capable of backing up your Helm charts directly, your operator-based applications directly, or if you have applications just based on labels. So it should be completely application centric, being able to back up all these different types of toolings or different types of management mechanisms that are available today. The other side we also see is that because there is a lack of a standard application definition in Kubernetes today, what customers have been doing is they've been keeping a one-to-one mapping between a application and a namespace. As a result of that, backing up that namespace also becomes important. So While that may make your backup a little heavier than required, and it may require a different kind of operational hygiene to do a one-to-one mapping, it is still a method that is used by most customers today to map their applications or to define their application standards. The next point we see is from an application discovery perspective. Kubernetes has multiple concepts like workloads. You have stateful sets, you have daemon sets, you have replica sets, you have deployments. You have all these different kinds of objects or concepts, and you want to make sure that the solution provides a unified approach to protect anything and everything within the Kubernetes environment. We also noticed that today within the Kubernetes world, there is a lack of knowledge, there is a lack of skill sets. So the application discovery of making it, easy for the end user to select what he wants to back up, making it as simple as possible is becoming extremely important. We also noticed that labels are insufficient to do a backup. What if you miss labeling a object, and what if your application grows and you mislabeling a component of that application? Your backup would be incomplete. So as a result, there needs to be a solution that provides multiple views, which slices and dices a Kubernetes environment to present, your application toolings, your workloads, just independent objects, whatever you may need to back up from a Kubernetes namespace or a cluster into any other namespace or cluster. And all this should be possible from a single pane of glass across multiple cloud or cross domains. Now that you have discovered your application, you want to make sure that you can take application consistent backups. So one of the things that we've been noticing is that the Kubernetes space is bubbling up with more and more stateful applications. When you have stateful applications, you have these persistent volumes. And when these applications are interacting with these persistent volumes, you want to make sure that your data is in a consistent state before you take a backup. And in order to do that, you want to make sure that the solution provides all the capabilities of hooks to inject specific commands into your container or into your specific pod. Now, these hooks also, there are multiple ways you can do this. Obviously, SSHing into a container is completely frowned upon. You cannot be doing that. But there are multiple techniques that can be used in terms of running exec commands against the container or running HTTP request against some web or REST API of the application. So whatever constructs are provided by the hook should fit into these different methodologies that are provided by the application. And once you've defined the hooks, you always want to make sure that you do not have to manually keep protecting your application over and over again. So you want to make sure that you have feature-rich scheduling policies to schedule, full backups or incremental backups. And at the same time, you want to make sure you have feature-rich retention policies as well, which can align with compliance regulations within your organization. So you would want a simple, easy approach to make sure that you can specify, hey, I want my weekly backup to exist for a year, or I want to keep 10 monthly backups, or I want to keep 15 yearly backups. All that should be easy to define and use. We've spoken about how important security is. And as part of defining the backup, you also want to make sure that the solution is able to encrypt your data that is being protected. Now, encryption does not just mean applying a hashing algorithm to protect the data, but also means key management. So, encryption, along with key management, becomes an important aspect of data protection. The next one in line is the target repository or the backup repository where you're going to be storing the data. Now, object storage has been becoming extremely popular. S3 has become one of the main object storages out there. because of its low cost, the scalability that it provides, and obviously the high availability that is available from it as well. So supporting object storage, whether it's obviously in the cloud or on-prem, is highly required. And then from certain customer environments, they already have a bunch of different file servers or existing storage systems that are providing file-based protocols. So supporting protocols like NFS become very important as well. Next, when you're protecting these applications with their data, you want to make sure that you're storing them in a non-proprietary backup schema. The reason for that is you want to avoid vendor lock-in, and you want to ensure that your data can be accessed even without the data protection vendor for doing additional innovation or additional building additional newer workflows. For example, you may want to capture the backup data or do some analytics on the backup data for additional machine learning activities. So making sure that the backup is not protected by a proprietary schema becomes extremely important. Now, from a restore perspective, we've backed up our data, we stored it in the target. Now, when you are at the level of restoring the application, you want to make sure that your application provides selective restore, which means you should be able to pick specific items from the backup to restore. It should also be able to provide granular restore. That means if you have specific database items, like tables or email items or certain things like as such, you should be able to capture those as well. And then finally, we are living in this highly abstracted environment. So the way an application behaves in cluster one will be different than how it behaves in cluster two because of these abstractions. So you want to make sure you have the ability to transform the data before it gets restored. For example, the storage class in cluster one could be called X, but the storage class in cluster two could be called Y. So making sure that your solution enables you to do that is also extremely important. Now we know that we all live in a B2B world. There's no one fit or one solution that fits everyone's needs, and you want to make sure that whatever solution that do you do uptake and you do adopt easily fits into the default tools or the default constructs mechanisms that are available in Kubernetes today. So, for example, Prometheus, Grafana, which are the standard monitoring and visualization tools, you want to make sure that the data protection solution fits into these mechanisms as well. And also from logging, Fluentd has been becoming extremely popular. So making sure that from a logging perspective, all well-formed logs are sent to a central repository like Fluentd is also highly required. Now we know that everything in Kubernetes, everything is a hot solution, is a new emerging solution. Now, how do you make sure that what you are deploying within your environment is the right piece of software and you're not introducing any loopholes? Now, we know that there are, Kubernetes is new, but there are vendors like Red Hat, IBM, and others who have been in the space for a very, very long time. These IT giants actually provide multiple certification mechanisms to certify a Kubernetes application, which makes sure that you are doing all the right things in terms of interoperability, security, network access, resiliency, and how it's being implemented. So having this certification, provides peace of mind to the end user that whatever solution you are engaging to touch your data is doing it in a rightful fashion. And then lastly, efficient handling of data. As we said, the term data protection is not new. Data protection has been happening for a while. How you do it in Kubernetes is different. But you always want to make sure that the solution that you're empowering or you're adopting again is not just taking all your data and dumping it into a backup repository, but it is doing it in an efficient fashion. providing space efficiency through deduplication, providing cost savings by sending less data over the wire becomes paramount. We also see there are a lot of different open source solutions emerging in the market. So making sure that your solutions are properly supported by a well-known vendor with a good history and track record of doing data protection becomes important. So with that, we'll quickly go over the 10 reasons that we just covered. So firstly, we want to make sure that the solution is Kubernetes and cloud native. We want to make sure that you're able to back up your Helm operator label-based applications as well as namespaces. You want to make sure that the solution is able to discover your applications and present that to you in an easy fashion. You want to also ensure that the solution has the capability of providing application consistent backups with policies and scheduling. Want a different or multiple choices for backup repositories. These can be object storage, AWS S3, on-prem S3, or can be Azure Blob. Also providing choice with file-based storage. You want to make sure that your data is accessible even without the vendor being in the picture. So open universal backup schema. And then being able to do intelligent restores. You backed up everything, but you might only want to restore a piece of it. Integrations and visualizations. We live in a highly distributed, complex world. So making sure that we have the right integrations and visualizations is highly important. Finally, everything in Kubernetes is new. Making sure that you have the right certifications and a solution that has been vetted externally becomes very important as well. And then finally, we've mentioned that data protection is not new. You want to make sure that whatever technology that you adopt can handle your data effectively. Now, there are different use cases that get possible as part of data protection. Backup and recovery is one, disaster recovery is the other one, and then application mobility, taking copies of your production data, moving it back into test and dev to do analytics or build additional pipelines out of it become pretty interesting. And then finally, we live in a distributed hybrid world, multi-cloud world. Making sure you're able to migrate your application also becomes one of the key use cases. So with that, I conclude the presentation portion of it. Ron, how are we doing on time?
Well, it was a little bit longer, but there was such great content, I just could not cut you off. And I wanted to make sure we got through all 10 items, which is so informative, and giving all of our attendees a chance to understand the power of the Trilio platform.
Okay, thank you, Ron. Yes, and just if folks want to get in touch, that's my Twitter handle. They can log on to Trilio.io, TrilioVault for Kubernetes. There are multiple demos, online labs. You can download the product for free to play around with it as well. But overall, you can come and see how we are addressing all these challenges in a cloud native landscape.